Hello students, I hope you all are fine and taking very good care of your health. Today we are going to take chapter number 9, class 9 science, force and laws of motion. Students, before starting the chapter, let me ask you a few questions. First question, do you know what is force? Yes, your answer is right. Force is a push or pull that tends to change the state of rest or motion, position, direction, or the shape of the object. Now, can you tell me what is motion? And yes, you know about the motion. An object is said to be in motion if it changes its position with respect to the surroundings. Students, we all know about the definition of the motion, but do we know how this motion is created and what is the real cause behind the motion? The same problem was faced by the scientists for more than centuries. Now, let me give you a situation. If I kick a ball, it moves a certain distance, then it comes to rest. What do you suggest about the observation? You will say that the state of rest is the natural state of an object. This remained the belief for centuries till Isaac Newton and Galileo put forward the laws of motion. In today's session, we are going to study about the laws of motion in detail. In today's session, we shall learn about balanced and unbalanced forces, first law of motion, inertia and mass, second law of motion, third law of motion, conservation of momentum. Students, do you know about balanced and unbalanced forces? Let us try to understand these. For this, take a balloon and tie it from both sides with thread. Place it on a smooth surface so that friction is minimum. Now we shall see the changes in the shape and motion of balloon on the application of force. First of all, pull balloon on left side, then on the right side. Now pull it from both sides with equal force. What are your observations? In the first case, the balloon moves to the left side, and in the second case, it moves to the right side. And in third case, balloon doesn't move, but there is a change in the shape of the balloon. In first and the second case, unbalanced force act on the balloon and balloon moves. It means to move an object, we need to apply an unbalanced force. In third case, force was applied from both sides, but both forces cancelled the effect of each other. Since these forces were equal to each other, and so they cancelled each other. And one more fact, that they were opposite to each other, that is, they were in opposite directions. We may say that these forces balanced each other. So students, those forces which do not make object to move and are only able to change the shape of the object are called balanced forces. Let us now see how Galileo explained about balanced and unbalanced forces. According to Galileo, if an object is moving with a constant speed with no force acting on it, it will continue to move on frictionless surface. Let us understand it in detail. Take two smooth pieces of wood. With these pieces, make two inclined planes with same angle of inclination. These planes should be frictionless, or there should be very less friction. Now roll down a marble from the left inclined plane. It rolls down the slope and go up on the opposite side to the same height from which it was released. That is, if the inclinations of the planes on both sides are equal, then the marble will climb the same height, that is, it will cover the same distance that it covered while rolling down. Now reduce the angle of inclination of right side plane. We will notice that the marble will travel further distances till it reaches the original height. And if the right side plane is ultimately made horizontal, that is, the slope is reduced to zero, the marble will continue to travel forever, trying to reach the same height that it was released from. The unbalanced forces on the marble in this case are zero. It suggests that an unbalanced force is required to change the motion of the marble, and no force is needed to sustain the uniform motion of marble. Students, let us now study laws of motion. Famous scientist Newton further studied Galileo's ideas on force and motion and presented three fundamental laws that govern the motion of objects. These laws are called Newton's laws of motion. Let us now discuss the first law of motion. Students, we know that in order to make an object move or stop a moving object, force is needed. You must have seen that a ball comes to rest after being kicked, but ball should have kept moving till an external force is applied to stop it. This is what Newton's first law is. Every object remains in the state of rest or of uniform motion in a straight line unless compelled to change the state by an applied force. It means if an object is in the state of rest, it will stay in the state of rest, and if an object is in the state of motion, it will try to stay in the state of motion. This property is also called inertia, and this way first law of motion can also be called law of inertia. Inertia can be of three types: inertia of rest, inertia of motion, inertia of direction. Experiences that we come across while traveling in a bus can be explained on the basis of law of inertia. When bus begins to move suddenly, then a passenger standing in the bus tends to fall backwards. Can you tell why this happened? This is due to the inertia of rest. Because of sudden start of the bus brings motion to the bus as well as the feet of the passenger in contact with the floor of the bus. But the rest of the body opposes this motion because of its inertia. It means an object effort to stay in the state of rest is called inertia of rest. Similarly, when a bus makes a sharp right turn at a high speed, passengers fall on the left side. It means inertia of direction opposes change in direction of an object. In the same way, when driver applies a sudden brake to stop the bus, the lower part of the body comes to rest, whereas the upper part of the body tries to stay in the state of motion, and we fall in the forward direction due to inertia. This tendency of body to stay in the state of motion is called inertia of motion. This is why Newton's first law is also called law of inertia. To understand more about inertia, let us do some activities. Make a pile of similar carom coins. Attempt a sharp horizontal hit at the bottom of the pile using another carom coin or the striker. If the hit is strong enough, the bottom coin moves out quickly. Once the lowest coin is removed, the inertia of the other coins make them fall vertically on the table. So you just observed that how a pile of coins stay in the state of rest due to inertia. Let us try another activity. Set a stiff card covering an empty glass tumbler placed on a table. Set a 5 rupee coin on the card. Give the card a sharp horizontal flick with a finger. If we do it fast, then the card shoots away, allowing the coin to fall vertically into the glass tumbler. Isn't it magical? Yes, it is. But this happened because the coin tries to stay in the state of the rest due to inertia. So students, this shows that an object stays in the state of rest unless an unbalanced force acts on it. This property of the object is called inertia. Students, let us now study about second law of motion. You have observed that during the game of table tennis, if the ball hits a player, it does not hurt him. On the other hand, when a fast-moving cricket ball hits a spectator, it may hurt him. A truck at rest does not cause any harm to anybody, and it does not require any attention when it is parked along a roadside. But a truck at a speed as low as 5 km per hour can kill a person standing in its path. A small mass such as a bullet may kill a person when fired from a gun. These observations suggest that impact produced by the object depend upon their mass and velocity. Similarly, if an object is accelerated, we know that a greater force is required for greater velocity. In other words, there appears to exist some quantity of importance that combine the object's mass and its velocity. One such property called momentum was introduced by Newton. The momentum p of an object is defined as the product of its mass m and velocity v. That is, momentum p is equal to mass m into velocity v. Momentum has both direction and magnitude. Its direction is same as that of velocity. The SI unit of momentum is kilogram meter per second. Let us now consider a situation in which a car with a dead battery is pushed on a straight road so that its speed is sufficient to start its engine. A continuous push over some time results in a gradual acceleration of the car to this speed. It means that the change of momentum of the car is not only determined by the magnitude of force but also by the time during which the force is exerted. It may then also be concluded that the force necessary to change the momentum of an object depends on the time rate at which momentum is changing. This is what second law of motion is. And the second law of motion states that the rate of change of momentum of an object is proportional to the applied unbalanced force in the direction of force. Let us now see the mathematical formulation of second law of motion. Suppose an object of mass m is moving along a straight line with an initial velocity u. It is uniformly accelerated to velocity v in time t by the application of a constant force F throughout the time t. The initial and the final momentum of the object will be P1, that is initial momentum, is equal to m into u, and P2, final momentum, is equal to mv. The change in the momentum is directly proportional to P2 minus P1. Now, filling the values of P2 and P1, the change of momentum is proportional to mv minus mu. Taking out m common, we have now m into bracket v minus u. Now, the rate of change of momentum will be proportional to m into v minus u upon t. And the applied force now, F, will be directly proportional to m into v minus u upon t, because applied force is equal to the rate of change of momentum. Now, F is equal to, taking away the proportionality sign, K m into v minus u upon t. And we know acceleration is equal to v minus u upon t. So, the expression is F is equal to K m a. The quantity K is a constant of proportionality. And now, The SI unit of mass and acceleration are kilogram and meter per second square respectively. The unit of force is so chosen that the value of the constant k becomes 1. For this, one unit of force is defined as the amount that produces an acceleration of 1 meter per second square in an object of 1 kg mass. That is, 1 unit of force is equal to k into 1 kg into 1 meter per second square. Thus, the value of k becomes 1. And now the equation is F is equal to ma. The unit of force is kilogram meter per second square or Newton, which has the symbol N. Now let us take third law of motion. The third law of motion states that when an object exerts force on another object, the second object instantaneously exerts a force back on the first. These two forces are always equal in magnitude but opposite in direction. This force acts on different objects and never on the same objects. A child kicks a football with 10 Newton force, then ball applies 10 Newton force on football, but in opposite direction. Similarly, a man applies 100 Newton of force on a wall, and the wall also applies 100 Newton of force on man, but it is also in opposite direction. These opposite forces are called action and reaction. Let us consider two spring balances connected together as shown. The fixed end of balance B is attached with a rigid support like a wall. When a force is applied through the free end of the spring balance A, it is observed that both the springs balances show the same reading on their scales. It means that the force exerted by spring balance A on balance B is equal but opposite in direction to the force exerted by the balance B on balance A. Any of these two forces can be called as action and the other as reaction. This gives us an alternative statement of the third law of motion, that is, to every action there is an equal and opposite reaction. However, it must be remembered that the action and reaction always act on two different objects simultaneously. Now, let us suppose you are standing at rest and intend to start walking on a road. You must accelerate, and this requires a force in accordance with the second law of motion. Which is this force? Is it the muscular effort you exerted on the road? Is it in the direction we intend to move? No. You push the road below backwards. The road exerts an equal and opposite force on your feet to make you move forward. The road exerts an equal and opposite force on your feet to make you move forward. Similarly, when a gun is fired, it exerts a forward force on the bullet. The bullet exerts an equal and opposite force on the gun. This results in the recoil of gun. Since the gun has a much greater mass than the bullet, the acceleration of the gun is much less than that of the bullet. The third law of motion can also be illustrated when a sailor jumps out of the rowing boat. As the sailor jumps forward, the force on the boat moves it backwards. So this was the explanation for the third law of motion. Now let us take conservation of momentum. Suppose two objects A and B of masses ma and mb are traveling in the same direction along a straight line at different velocities ua and ub respectively, and there are no other external unbalanced forces acting on them. Let this force ua is greater than ub, and the two balls collide with each other as shown. During collision, which lasts for a time t, the ball A exerts a force FAB on the ball B and the ball B exerts a force FBA on ball A. Suppose VA and VB be the velocities of the two balls A and B after the collision. Now the momenta, plural of momentum of ball A before and after the collision are MAUA and MAVA respectively. The rate of change of its momentum FAB during the collision will be MA into VA minus UA upon T. Similarly, the rate of change of momentum of ball B, that is equal to FBA, during the collision will be MB bracket start VB minus UB upon T. According to third law of motion that we have studied, the force FAB exerted by the ball A on the ball B and the force FBA exerted by the ball B on ball A must be equal and opposite to each other. Therefore, FAB is equal to minus FBA. Now, substituting the values, FAB, MA, VA minus UA upon T is equal to minus, in the place of FBA we will write MB bracket start VB minus UB upon T, and this will give us MA UA plus MB UB is equal to MA VA plus MB VB. Since MA UA plus MB UB is the total momentum of the two balls A and B before the collision and MA VA plus MB VB is their total momentum after the collision, we observe that the total momentum of the two balls remain unchanged or conserved provided no external force acts on them. So this is the law of conservation of momentum, and students, we have to remember it. Students, now let us try to solve some questions based on conservation of momentum. For this, we will take an example. A bullet of mass 20 gram is horizontally fired with a velocity 150 meter per second from a pistol of mass 2 kg. What is the recoil velocity of the pistol? First of all, we know mass of the bullet, let it be m1, is equal to 20 grams. Let us convert it into kgs, 0.02 kg. Mass of the pistol m2 is equal to 2 kg. Let initial velocity be u1, and in this case, initial velocity of bullet u1 is equal to 0 and initial velocity of pistol u2 is also 0. After firing the bullet, final velocity of the bullet v1 is equal to, as given above, 150 meter per second, and we have to find the recoil velocity of the pistol. Let the final velocity of the pistol v2 be v. Now, we know that according to law of conservation of momentum, m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2. Now, as we know that u1 and u2 are 0, so the left hand side will be 0. So, let us take 0 on the left hand side, and now substitute the values on the right hand side. For m1, let us take 0.02 kilograms into v1, that is 150 meter per second, plus for m2 we have 2 kgs, and for v2 we have supposed it to be v meter per second. Now on solving, 0 is equal to 3 plus 2v, 3 plus 2v is equal to 0, 2v is equal to minus 3 and v is equal to minus 3 by 2. So we have the value v is equal to minus 1.5 meter per second. Negative sign indicates that the direction in which the pistol would recoil is opposite to that of bullet. That is, if the bullet goes to right side, then the pistol will go on the left side. Now let us take one more example. A girl of mass 40 kgs jumps with a horizontal velocity of 5 meter per second onto a stationary cart with frictionless wheels. The mass of the cart is 3 kgs. What is her velocity as the cart starts moving? Assume that there is no external unbalanced force working in the horizontal direction. So students, here we have a case where the girl jumps on the cart. So now, first of all, let us write down mass of the girl, let it be m1 is equal to 40 kg, and she is jumping on the cart. Let the mass of the cart m2 is equal to 3 kg. So 3 kg is the mass given here. It is given that initial velocity of the girl u1 is equal to 5 meter per second as she jumps on the stationary cart, and we know that cart is stationary. So let u2 be the velocity of the cart, and u2 here is 0 meter per second. Now girl is on the cart after jumping, so both of them will have the same velocity. So final velocity of the girl v1 is equal to v, say it be v, and the final velocity of the cart v2 is also the v. By law of conservation of momentum, we know m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2. Now substituting the values, for m1 we have 40 kgs and u1 is 5 meter per second. For m2 we have 3 and u2 is 0, and similarly on the right hand side m1 40, v1 v plus m2 3 and v2 v. On solving we have 200 is equal to 43 v, and v is equal to 200 upon 43, and on solving we get 4.65 meter per second. So the girl on the cart would move with a velocity of 4.65 meter per second in the direction in which the girl jumped. Now let us revise what we have learned till now. Now the first law of motion. An object continues to be in the state of rest or of uniform motion along a straight line unless acted upon by an unbalanced force. We also studied second law of motion, that is, the rate of change of momentum of an object is proportional to the applied unbalanced force in the direction of the force. The SI unit of force is kilogram meter per second square. This is also known as Newton and is represented by the symbol N. A force of 1 Newton produces an acceleration of 1 meter per second square on an object of mass 1 kg. We also studied that momentum of an object is product of its mass and velocity. We studied third law of motion, which states to every action there is an equal and opposite reaction and they act on two different bodies. Now the questions. First question, a batsman hits a cricket ball which then rolls on a level ground. After covering a short distance, the ball comes to rest. The ball slows to a stop because these are the following reasons, and you have to choose the correct reason. First reason is the batsman did not hit the ball hard enough. Velocity is proportional to the force exerted on the ball. There is a force on the ball opposing the motion. There is no unbalanced force on the ball, so the ball would want to come to rest. And can you guess the correct answer? Yes, the answer is there is a force on the ball opposing the motion. Otherwise, it would have kept going. Now, let us take the another question. What is the momentum of an object of mass m moving with the velocity v? Options are brackets mv whole square, mv square, half mv square, or simply mv. So students, we have studied about the momentum and its formula. Can you tell me the right answer? Yes, option D is correct. mv, P is equal to mv. And the next question, when a carpet is beaten with the stick, dust comes out of it. Can you explain why? Try to suggest some answer. Yes, the right answer is, when we beat the carpet with stick, it comes to motion, but due to the inertia of rest, dust particles try to stay in the state of rest and fall down. Now the next question, what is the SI unit of momentum? Yes, it is kilogram meter per second. Next and the last question, what is the SI unit of force? So you may give either it as Newton, that is represented by N, or kilogram meter per second square. Students, with this we finish our chapter and I hope that you have understood the chapter well. Now go through the chapter from your textbook and try to answer the questions given in the exercise. Students, keep studying, keep progressing, stay healthy and stay safe. Thank you, students.